Okay, Assalamualaikum guys. We go to the first topic in this course, which is definition and terminology used in the differential equation. So what is DE? So DE represents the problem of phenomenon involving the relationship or the changes of some variable of interest with respect to another variable. For example, I have dV over dt, means that the rate of change of volume with respect to the rate of change of time. In other words, you can define that the rate of change of volume depend on the time. So principally, we can define differential equation as an equation that contains the derivative, means that it must have derivative. Otherwise, if it doesn't have derivative, it considered as an algebraic equation. It must contain the derivative of one or more dependent variable with respect to one or more independent variable. So after this, you will learn what is dependent and what is independent variable. So there are many out there, the example or application that use DE, and some of them are Kirchhoff's law, Newton's second law of cooling, for example. So this is the common one. So now we go to the classification of DE. Basically, DE can be classified based on the type, order and linearity. Before that, I want you to be familiar with notation used in DE. In DE. So we have three, basically Leibniz. There is prime notation and dot notation. So Leibniz is the common one. Leibniz is the common one. Just dy dx, dy over dx square. So prime is y for y prime for first order, y double prime for second order, dot. We replace prime with dot, to the upper of derivative. Y dot means that first order, y double dot means that second order, and normally dot is used by the physics. So you have to take note here. If we have if fourth order onwards, we use number in parentheses. Number in parentheses. Why we don't use this prime? Because logically, if you have 100 prime, you want to write the 100 prime? Not right. So we use number in parentheses to show the order of DE. So another thing that you have to take note, y sub 4, in a bracket or in parentheses not equals to y to the power of 4, because for the first one here, 4 in parentheses represent what? Represents the order. So for the second terms here, it represents the power. So both of notation give you different meanings. So we go to the first classification, which is by type. So basically there are two types, which is ODE, for ordinary differential equations, and PDE for partial differential equation. So ODE, we go to definition of ODE. It represents the derivative of one or more dependent variable to single independent variable. What does it mean? Regardless how many dependent variables that you have, it must depend on the only one single variable. This is the keyword, single independent variable. So look at the example here, dy over dt. Which one is dependent, which one is independent? So if we interpret this equation, it means that the change of y with respect to t, or the rate of change of y is depend on t, means that y is your dependent variable. The upper one is your dependent variable, Meanwhile, the bottom one is independent variable. So it must have, for ODE, it must contain only one independent variable. Means that you have to look at the denominator here. Only one independent variable. Okay. For the second one, okay, for the second example here, you can see at the bottom we only have x as your independent variable. Okay. And okay, here also one dependent. So how about the third example here? For third example, okay, also one independent variable, which is t, so independent. Okay, but this time we have two dependent, y and u is your dependent. So I repeat again that ODE, it must only have one independent variable regardless of how many dependent variables that you have. So we go still on the type, by this time is PDE. So PDE, okay, the keyword here contains two or more independent variables, unlike ODE. So for ODE, contains one independent variable only. Okay, independent variable. Okay, meanwhile for PDE contains two or more independent variable. So we go to, for example, here you look at the bottom, because we know at the bottom is your independent, right? So we have x and y, means that two independent variables. So this equation is known as PDE equations. Okay, so independent variable. So we have here only one dependent, okay, regardless how many dependent variable, but if it contains two or more, it classifies as a PDE. So if you notice here, even the notation used for the PDE is a bit different from the ODE, because here, okay, if you notice, you use a curly D, which represents the small change, or delta, which represents the small change. Unlike the ODE, we use straight D, right? Okay, big change. Okay, so for the second example here, also we have two independent variables, okay, y and x. Similar like third equation here, we have x and t, two independent variables. So this equation is classified as PDE. So second, okay, classification is based on order, where it means that in equation it must look into highest derivative, okay, or highest order. So we go to the first example here. Okay, we look into derivative dy dx. Okay, the order here is the first order. This is the highest derivative. Okay, for the second example here, between cube and 4 here, okay, 4 is the highest one. So the highest order is fourth order for the second example. Okay, for third example here, the highest order is 2. Why not 3? Because 3 here represent what? Okay, represent power, as I mentioned before. If, okay, 3 in bracket means the order, so the power here. So for dy over dx cube here, okay, the order is 1. Order is 1. Okay, and the power is 3. So we look into the highest order, means that, okay, in classification by order, okay, it is not determined by the power. Okay, you have to take note on this. So the third classification is by linearity. Okay, so to be linear, three properties need to be fulfilled. Okay, first, the power of dependent variable and its derivative must be equal to 1. So from example here, we know that our dependent variable, okay, is y. Okay, and look at the power. Okay, dependent variable is y, so the power here is 1. Okay, so how about its derivative? Because it's stated that the power of dependent variable and its derivative. So its derivative y prime and y double prime here, the power is also 1. Okay, so means that this example is linear ODE. So let's say I modify a bit, y double prime square minus 2y prime plus y cube equals to 0. So now it becomes nonlinear because here, okay, the power of dependent variable is not equals to 1, and the power of derivative here is also not equal to 1, which is 2 here. Okay, so now it becomes nonlinear. So second properties is there does not exist any nonlinear function of dependent variable. So what does it mean? Okay, so look back at your example here. Okay, as we know that linear function is function that exists. Okay, the power of y is equals to 1 here. Y equals to mx plus c. Other than is nonlinear, right? So let's say you have y square, means that this is a quadratic function which is nonlinear function. Ln y is also nonlinear function. Any triangle function, cos, tangent, okay, secant, sine, okay, all those are nonlinear function. So if there is exist any nonlinear function of dependent variable, so the DE is classified as nonlinear. So for the first example, as we can see, there is no nonlinear function existed, but let's say if I change this equation to be y double prime minus 2y prime plus ln y, now it's become nonlinear because there exists nonlinear function of ln y, which is belong to dependent variable. So the third property does not exist the product of dependent variable and its derivative. Okay, so for example, I give you y multiplied with y double prime minus 2y prime plus y equals to 0. So this equation is nonlinear because as we can see here, y, okay, y is dependent variable, and the variable is multiplied with its derivative. So in other words, if we see that, okay, y and its friend or its derivative is multiplied, okay, it become nonlinear one. So other example, okay, if we say that y double prime minus 2y prime multiplied with y double prime plus y equals to 0. This equation is also nonlinear, okay, nonlinear because there exists the product between here, derivative y prime and y double prime. So basically, nonlinear ODE is contain nonlinear terms of dependent variable and its derivative. Okay, we go to for example here. It is nonlinear because contain, okay, nonlinear function of dependent variable. This is y here. So exponent is nonlinear function. So for the second example, okay, because product, there is this product between dependent variable y and its derivative, okay, y double prime. Okay, for third example, similar like first example because it contains nonlinear function of dependent variable. Okay, if we change it to x, okay, it becomes linear because x is belong to independent. Okay, so because y is dependent variable, so sine is nonlinear function, so it becomes nonlinear for this example. So for the fourth case, because the power of dependent variable y variable is not equal to 1. So all of this example is nonlinear ODE. Okay, there is another term that you need to know in the DE, which is verification of solution. Very easy. If let's say in question is already give you a solution. For example, okay, verify that y equals to s to the power of 4 over 16 is a solution. Means that is a solution to the given DE here, dy over dx, xy to the power of half on the interval, on the given interval. So we need to verify whether it's true that the given solution is a solution to the given DE. So what you have to do, first step is to, okay, differentiate the solution, okay, the solution to the highest order, of differential equation given. So here the highest order is 1. So differentiate the solution. Y equal to s to the power of 4 over 16. So I differentiate, we get s cubed over 4. Okay, so second step is substitute y and dy dx into the given DE. dy over dx equal s y to the power of half. So s cubed over y is your dy dx. Okay, x multiplied with x to the power of 4 over 16 is your y. Okay, just taking back, just write back your x here. Okay, and y to the power of half. Okay, just substitute what is your y. So when you simplify, you get right hand side and left hand side are similar. So when it is similar, means that verify the solution is true solution to given DE. Okay, I think this is the end of the first chapter. So see you on the new topic after this. Assalamualaikum.